So one of the things that affects the buoyancy of an object is the density. So if I have something like clay here, if I dump it in, it automatically sinks to the bottom. If I have something like a styrofoam ball, it will float. And then if I have something like a candle, it will actually float as well. When things sink, like our clay did in here, it's because it has a higher density than the water does. But when things float, like these two, it's because they have a lower density than the water does. Our clay just sinks right to the bottom because it's so dense that the water can't handle that pressure. We know that our styrofoam ball has a lot more air inside of it, which makes it easier for it to be lifted up. Our candle actually also floats as well, even though it's the same shape and size as our clay. So it doesn't really matter how something looks, it's just all about its density. Another factor that affects buoyancy is surface area. So if I have this boat that I made and then just a piece of paper, I can put my paper in, put some crayons on it, and it cannot hold them. It automatically sinks. But if I give my boat a try and I put the same crayons on there, my boat is able to still float because it has that higher surface area. This cup is empty, right? Nothing in it? Wrong, because this cup is filled with air. Now, if I was to put this cup in our water, you would think that my cup is just filled with water now, but you're wrong, because air holds volume. Our air is less dense than our water is. That's why it causes heavy objects, such as this glass, to float. This glass is more dense than the water, and if we fill it up with water, we can see that it just sinks. However, if we add air pockets to it, like this, it will float, and that's because we reduce the overall density of the glass with those air pockets. If you guys enjoyed watching this video, you should come to the Science Center so you can see us perform some cool shows.